Hi everyone, I'm Kirsten Ellis. I'm the Coastal Adaptation Specialist at CBUS. I specialize in nature-based adaptations and I'm presenting the Belcher Street Managed Realignment and Tidal Wetland Restoration Project. This project was a collaboration between the Nova Scotia Department of Agriculture, CBUS, St. Mary's University, marsh body landowners, and the DFO Coastal Restoration Fund. The Belcher Street Dike land is located near Kemptville, Nova Scotia on the Cornwallis River. Prior to restoration, the site was fallow and active agricultural land protected by 1.34 kilometers of dike. The dikes were built close to the riverbank, creating a long, winding dike system that eliminates the natural floodplain, something we commonly see throughout the Bay of Fundy. The main issues at the site were erosion and failure of the dike system, inadequate drainage, and potential overtopping during storms and storm surges. All of these climate-related issues resulted in access concerns, decreased protection of agricultural lands, and increased maintenance costs of dike infrastructure. Managed realignment involved moving back and straightening the dikes to reduce the length of dike infrastructure, resulting in the restoration of 9.7 hectares of floodplain and tidal wetland habitat, contributing to the resiliency of the dike and river system, while reducing flood risks in the towns of Kemptville, New Minas, and Port Williams. The project began in 2017 with a feasibility and design study, marsh body consultation, and the implementation of a long-term monitoring program. Construction occurred in May and June 2018 and included building 565 meters of new dike set back from the bank, raising 240 meters of existing dike to climate change standards, and leveling over a kilometer of old dike to wetland elevations. The project also included excavation of a historical tidal channel. Restoration of tidal wetland habitat resulted from introduced tidal flushing and local seed sources. The hybrid living shoreline used inverted root wads, a rock toe, and native plants to stabilize a section of the eroding riverbank. This project was a true win-win-win. There was a net gain in the area of provincially significant salt marsh habitat. Landowners got improved access and increased protection of agricultural land. And the length of dike infrastructure was reduced, while accommodating climate change-induced sea level rise by restoring the natural floodplain and piloting hybrid living shoreline techniques. One of the challenges of this project was not having local examples of similar projects. This was overcome by research and presenting international examples, as well as the willingness of individuals to experiment and try new management techniques. And that came from trust and the strong relationships between the decision makers and the restoration team. Another challenge was the unintended impacts of construction equipment on the site and how that altered the way water flowed across sections of the site. This was overcome by adaptive management and small modifications to the site, including wattle fences to slow water and trap sediment, as well as native transplants to accelerate vegetation recovery. Small softwood trees were installed between the root wads to trap sediment and reduce scour and channel formation. So far, these nature-based adaptations are working. A challenging discovery that has come out of the project is the realization that the living shoreline was more expensive to implement than the traditional rock armoring. I believe that ongoing monitoring of the performance of the living shoreline will show that it is the more cost-effective option over time. Thank you for your time. Thank you to everyone at the New Brunswick Environmental Network for organizing this conference. And thank you to everyone who participated in this unique project, showcasing multiple nature-based adaptations in Atlantic Canada.